take the circle function, y equals 1 square root 1 minus x squared. This is a semicircle, okay, where we have the radius of 1. So it's basically going to be the half circle. We could do the plus minus if we wanted to, okay, but we'll just start with a half circle just so that's easier. Where if we were going to vertically expand this by 3, it would look like this. Okay, so I have my y equals, okay, so we're going to multiply vertically by 3. There's my vertical expansion by 3. And I'm going to do a horizontal expansion by 2. Okay, so I'm going to get a horizontal expansion by 2. I'm going to do like that. Okay, going to divide by 2 like that. Okay, so if I then rearrange this to solve the equation in the circle form, okay, the x squared plus y squared equals r squared form, I rearrange this. The first thing I would do is I need to bring the 3 down. Okay, I need to undo the square root. I'm going to square both sides, so I'll do it in a few steps here. Okay, so there's my compression factor or expansion factor of 3 showing up in the denominator here. There's my expansion factor of 2 showing up in the denominator there. When I rearrange this, I'm going to end up with x over 2 squared. Okay, and then I'm going to have plus y over 3 squared. Okay, and then that's going to be equal to my positive 1. Okay, and typically we don't write it in this factored form. We typically will write it in this way. We would rearrange it into x squared over y squared over equals 1, and then it's going to be x squared over, so it's going to be y squared over 3 squared, and then it's going to be x squared over 4 like this. And we can see that our x-axis radius is 2, our y-axis radius is going to be 3 based on our vertical and horizontal expansions. So when we do this, we're going to end up with a horizontal of expanded by 2, and then we're going to see our vertical expanded by 1, 2, 3, so it's going to be up here, so it's going to be some graph, an ellipse that kind of looks like this. Okay, so when we actually graph this, the way we would do it from the ellipse perspective is we just take a look at that and say, well, I know my x-axis radius is 1, 2. 1, 2. Okay, so I can mark those points. That's my horizontal radius. I can then take my y-axis radius of 3, 1, 2, 3, mark my y-axis radius of 3, and 1, 2, 3, negative 3, okay, and then I can sketch in my ellipse that way. So I get the exact same thing as I had before, and I could do it from a function perspective like this, and I get this kind of looking graph. But this is much easier to do if we can just understand how do those expansion and compressions relate to the ellipse. Okay, so it's really we're just really talking about the x-axis radius and the y-axis radius that are going to come out of those terms of A and B. So let's take a look at this. So then basically there's some terminology we need to be clear on. The long axis is going to be our major axis. The short axis is our minor axis. Now it could look like this. Now even if we switch it around, okay, so let's say we have our axes now like this, our major axis then switches to the y. Okay, so this is now our major. Write that properly. Major axis. Okay, it can switch, right? Before it was minor, now it's long, it's major. Okay, that goes with our y. Our minor axis, okay, now is a short axis. So this is now the short axis, doesn't matter if it's x or y, that's going to be our minor axis. Okay, in this case, that's our x-axis, that goes with the A. It's now the minor axis. This is our major axis because it's longer, and it goes with the A with the x. Okay, so when we want to graph these are centered at 0, 0. What I can do then is, really all I need to know is my A and B values. My A is my x-axis radius, which is a square root of 36. My B then is my y-axis radius, which is going to be the square root of 16. So then to draw this, I just need to draw my y-axis radius, 1, 2, 3, 4 from the center. Okay, and my x-axis radius is going to be 6 from the center. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. There are my vertices. Maybe I should list those points. That's going to be 0, 3, 0, negative 3. This is good. Oh, sorry, that's not going to be 3. It's going to be 4, isn't it? 0, negative 4. Okay, 0, 4. Okay, this is going to be 6, 0. This is going to be negative 6. 0 is my coordinate. And I have my nice ellipse that's going to be drawn through those vertices.